Hello everyone. In this video, we are going to cover 5G features and parameters part 2. The main target of this small tutorials is just to cover the high level understanding of those features and parameters. In addition to this, to try to figure out together how to verify the features functionality from field testing or from the traces. So let's go move forward. So this will be the today main agenda. First, I will be covering three main parameters and features related to DMRS for PDSCH. First one is multiplexing the PDSCH channel with PDSCH DMRS. Then we'll be discussing about the double symbol and the additional symbols for the PDSCH DMRS. And lastly, we'll be ended by the SRS transmission methods. Before going into the three features related or parameters, feature and parameter related to the DMRS PDSH, we'll be covering first the overview, covering the overview of DMRS, how it's working, what is the characteristic, and so on, just to have a high level idea before digging into the. Okay, before moving into the details or features and parameters related to the BDSH DMRS, I first need to give you high level introduction about the DMRS for BDSH. So first, let's cover the main characteristic for DMRS. When I mention characteristic, it means like, for example, how the resource allocation, how the DMRS resource are going to be allocated, the symbols, number of RBs or frequencies, and so on. So the first part I need to cover about the DMRS characteristic, that DMRS is actually being all the time associated with BDCH in the frame. For example, if the user is having a resource allocation and using 5 resource blocks, this means DMRS will be available along and associated with the BDSH in the same 5 resource blocks. And if the user doesn't have any resource application, then the BDSH for DMRS will not be available at that time. This is the first part. The second part, that both are using the same antenna ports. Let's assume that currently BDSH is using antenna port, for example, 1000. This means DMRS also will be using the same antenna port. And one more part to highlight here about the characteristic, that actually the DMRS having a very flexible configuration. Okay, uh, what it means, it's having a wide range of configuration. Range of configuration. Let me show it to you here. DRS having wide range of configuration that it's needed actually for to accommodate with the scope of multi-user and single-user MIME. You can see here we have around six kind of configuration we can tune or play around to tune the DMRS resource allocation. For example, first part here something called type 1 and type 2 configuration, and second it's about something single and double symbol and so on here. And this is just related to BDCH duration. I will be covering today just a high overview about the type 1, and we'll go through some of those parameters which is related to the tuning and feature and so on. So the first part here, we are going to highlight about the DMRS configuration type 1. In configuration type 1, we can have single symbol of DMRS. What it means by single symbol? As you can see here, the DMRS now is being allocated in one symbol, one symbol. This all related to the PDSH, and DMRS is being associated in the first symbol of the PDSH. This is called front loaded. Okay, but the type 1, the main point about type 1, the resource element or the DMRS is being allocated in every second resource element. This means it's consume around 50% of the symbol associated with DMRS. It will consume around 50% of the symbols. This is if you are talking about single symbol. Okay, one of the main characteristic also for this part, that in DMRS type configuration type 1, we can have up to 4 ports. And if I'm now assuming that only 2 ports out of 4 are being used, for example, I'm using port 1000 and 1001. These 2 ports, for example, what it means by ports. Ports, for example, let's assume you have a single user. You have a single user MIMO with rank 1. This means that rank 1 will be only using one antenna port, which 1000. Okay, so it will be looking at the same figure like this one. It will be allocated every second sub resource element to this particular user which is using rank 1. Assume that this user is going to use rank 2 now. Then he need to consume additional port. You need to have 2 additional ports. If he is going to receive rank 2 or 2 layers, you need to consume 2 antenna ports. Okay, this is very important point. As you can see, still he's using the same resource element. There is no change because there is something called CDM or code division multiplexing, which is being used for the different ports to allocate within the same ports, but with using different codes. So in this case, the user still can use rank 2, for example, rank 2, and within the same resource element. And also we can assume, for example, you can have two users, each user is using one port 1000, port 1001, and both can be, for example, uh, using the same port, the different ports, but being like using code division or CDM, being like used within the same resource element. Okay, this is the first part. And as continuation, because this is very important, this is called, for example, CDM group 0. Now assume we have additional, for example, the user is going to use rank 3 now. Instead of rank 2, is going to have rank 3. So rank 3, this means you need 3 antenna ports. 3 antenna ports, this means, as you can see here, now this one is being used in different location, resource element location. So this means now I need, for example, here before there was no data transmitted at all, nothing being transmitted here. So in this case, this user have to fully use the resource element used in the DMRS. So in this case, for example, this will be the situation. The resource element will be allocated for this particular user to use rank 3 because he now is using 3 ports and is using port 3. Now assume he's going to take rank 4. This means he will be assigning the complete resource element, but with two code division multiplexing. The first two, for example, is being used for rank 2, but using CDM. Then this another two is called frequency multiplexing, with the remaining is taking the remaining frequency resources to being allocated for the remaining two ports. It's kind of looks complicated, but just to take it brief, this is very important as introduction for the next features, which will make it more clear. So now I just explained the DMRS configuration type 1, single symbol, where it's using 4 antenna ports. This means maximum, for example, assume that the user, a single user MIMO, can use up to 4, rank 4, receive up to, because he have only 4 antenna ports. Okay, this is the first part, which is very important to be highlighted. Now let's move forward for the features, and it will more clarify whatever we have mentioned here. Now moving forward for the same parameter or feature used for DMRS for PDSCH, it's called PDSCH multiplexing with DMRS. What it means by this? Okay, assume the previous example which we highlighted. Assume that we have a single user MIMO, for as example, is using 2 antenna ports rank 2, receiving rank 2, and is using those every second resource element. However, the remaining resource element are not being used and no any data is being transmitted here. So this means this resources is not actually used or is not actually utilized. So in this case, we need to utilize it. In this case, you can enable the PDSCH multiplexing with DMRS. And in this particular case, this will be the situation, as you can see in the right. That the DMRS now, the remaining no data can be transferred into PDSCH. So now this can increase your maximum cell throughput and maximum user speed, assuming that you will have now more resource element being added, because before it was only 50% of this particular sample, 50% of this particular sample not used for any data, which is here in gray color. Okay, two more points to highlight. First, assume that this particular user is in rank 4, right? If you remember, or rank 3. This means that the remaining data will be already utilized for DMRS as well. This means in this case we cannot have frequency multiplexing, PDSCH multiplexing with DMRS. This means that with rank 3 and rank 4, we cannot have PDSCH multiplexing with DMRS. This is the first part. Or with multi-user MIMO, because if you assume that you have another user using the different ports, in this case, also we cannot use we cannot have PDSCH multiplexing as long as all the resource element are being or subcarriers are being those being allocated to DMRS. In this case, we cannot have any frequency multiplexing. And there is one associated drawbacks as well, that in this particular case, whenever we don't have this not being used for any data, in this case we can have power boosting for the DMRS. We can use the remaining resource element power to be allocated for the DMRS, so this can improve your cell edge coverage. So assume now you enable this feature. This means you will lose and you have this kind of multiplexing. In this case, you will have a trade-off for the DMRS power boosting. So in this case, you cannot have power. This is impact your edge users. So my recommendation here in this part, that this kind of particular feature, it can first be used as a testing to increase the maximum user throughput. Secondly, it can be try to tune it as much as possible based on your network, to tune it to be used only for the users where they have a very good radio condition. That's the first point, because first of all, users if having very good radio condition, this means there is no need for power posting. Secondly, we need also those users to have high traffic or high demand users, because for example, if the user is not using the 4 resources, so the impact will be much less. So this is the first part about the DMRS. And this is here the summary that the gain, this can increase the maximum user throughput for users in a good radio condition where they are also using high demand user using most of the resources. Second, as a drawbacks, this will be trade off with DMRS power boosting, which can impact the edge users, and it's not supporting with rank 3, rank 4, or multi-user MIMO as we highlighted, because all the 4 ports or for the resource element will be utilized for DMRS. In that case, we cannot have any multiplexing. Moving forward for the next feature, second one is about the double symbol. For example, initially I explained to you about this configuration type 1 single symbol, right? First of all, this one is controlled by 3GPP parameter ID called maximum length. The name can be different in the vendors, but this is the 3GPP parameter name. It's called maximum length. If this one is set to length 2, this means we have now double symbols. What it means by double symbol? Okay, first let me again recall the single symbol. This was the figure of the single symbol where you assume that all the DMRS is being used. Double symbol, single symbol, it was using, as you can see here, for antenna ports, right? And double symbol, it will take the additional symbol and the second symbol here will have 2 symbols transmitted here, and the number of antenna ports actually will be increased to 8 instead of 4. It will be 8. It will be doubled. So in this case, if you increase the number of antenna ports, you can have more scope for multi-user MIMO. For example, instead of before having, let's assume that I have 2 users with rank 2. So before I have, for example, 2 users, first user is using two ports, this resource element, and the second user is using this. So this means I can have only 2 users, for example, for multi-user MIMO. However, if I increase double symbol, and the double symbol now I can have more antenna ports, so I can have more multiplexing, so I can have more users to be multi-user. For example, the first user can use rank 2 for the first 2 antenna ports, then and this will be CDM, code division multiplexed together. Then the second 2 ports 1044 and 1005 can be used also for second user, and so on. So in this case, we can have 4 users with rank 2 being allocated for multi-user MIMO. So as a summary, double symbol, the increasing the number of symbols, it's actually increased the scope of multi-user MIMO. However, it's also increased the overhead, and the overhead will impact the maximum user throughput as well, as you all of you know about this part. So this is the summary for this particular part. So as a summary, using pair of symbols increase the code multiplexing capability because you have more antenna ports, and 4 instead, for example, of 2 before, and this increasing number of antenna ports can increase the scope of multi-user MIMO. This is a summary for the second feature. Moving forward, for the last feature for DMRS, it's about the additional DMRS symbol. Okay, we spoke about the double symbol. Double symbol, we can have 2 symbols, for example, one here and one here. Now we can have additional symbols. And by the way, the first symbol coming here is called front loaded. This is by default, it's must. It can be 1, can be 2, and it can be 1 or 2. But this is must. It must be added. You can now have additional DMRS symbols. You can request, for example, to add 1 here, or even 2 and 3. This is a 3GP parameter name. It can also, again, vary from different to another, vendor to another. The name, I mean, but this is a 3GPP name. The first, as you can see, this is the range of the parameters. First, you can have position 0, means you don't have any additional, or you can have 1 additional symbols, or 2 additional symbols, or 3 additional symbols. But the most important part I will need to highlight here, that this one actually relying on UE capability. I will be showing this part at the end of this slide. I will be showing how to check the UE capability and so on. However, what is the gain we will have to add, for example, let's show you now we have this additional symbol. What is the gain of having now one additional symbol as example here? This is one front loaded only, and this is have 2 additional symbols. What is the gain of having this additional symbol? The gain of this part that we'll have now 2 time instant, right? And then we can interpolate it between them. Okay, we can have, so this actually reduces the gap between the channel estimation. What it mean by this? For example, assume now we have only 1 here, and you have to wait until the next resource block, right? Sorry, until the next symbol, I mean slot, to start again interpolate or start to modulate the new DMRS. So in this case, actually, you will have 2 time instant within the same resource block, which is in 2 different symbols. So this one actually reduce the requirement for the long interpolations. This particularly can be very important for high speed scenarios where the propagation channel change very rapidly. So the high speed scenarios can benefit from this part, which have a much better demodulation, and you can have a much better performance. We can, for example, perform a test in mobility mode, high speed, before and after having front loaded and 1 additional symbol. Okay, So this is as a summary for this part. But again, this as a drawbacks, it will increase again the overhead because you have already additional symbols. So this also can reduce your maximum user throughput. And as last part here, how to verify from field or from trace verification. Okay, first part that you need to check the UE capability because actually this rely on UE capability. Not all the UEs can support additional symbols. Let me zoom in here in this part here. Okay, zooming in here, you can see here this UE capability message. Under UE capability message, you can something called feature downlink, set downlink. Okay, you can see here you have one front-loaded DMRS. This is the capability of the UE. You can support one front-loaded, which is the first symbol here, with two additional DMRS. This user can support this one. And also you can support two front-loaded with two additional DMRS, or one front-loaded with three additional DMRS, which is the maximum configuration. Okay, this is the first part, how to verify from the U capability. Now, the master information block will be addressing the position. For example, DMRS type A, position 2. This means you have one additional symbol as mentioned here. And if it's 3, this means, sorry, this 2, this means you'll have 2 additional symbols. You have extra one here. If it's 1, this means you will have only 1. If it's 3, it means you will have 3 additional symbols and so on. And if the case, in case if the U is not supporting, he will be only using the front loaded and so on. So this is as a summary for this feature. And the last part in this slide. Now let's cover the SRS transmission tuning. Okay, I have a detailed video about the SRS for 5G. It's covering most of the related aspects and details for the SRS. You can refer to this video in case if you need to get more details. So just as a brief, let me tell you how this feature working. By default, the SRS is being transmitted by the UE over the complete channel bandwidth. Assume this is the channel bandwidth here. So the UE will transmit the SRS over the complete channel bandwidth. This means that SRS power will be distributed over all the resource blocks. Assuming here we have 128 resource blocks. Okay, so in this case, if you change it, the resource transmitted resources, tune the SRS transmission instead of full bandwidth, for example, to half bandwidth. So in this case, your power can be distributed among half bandwidth, so they can double your power. This can improve your edge user throughput, edge user coverage, SRS coverage. So in this case, what you will do, how you can do this one. Here, this is the 3G parameters name. Again, this can vary from the one different to another, with window to another as a naming, but the concept should be the same. Here, you have two parameters which can control this part. The first part called CSRS, and this is referred only to the full bandwidth. It's not a parameter. The parameter which is parameter which can control the whether to transmit at the full bandwidth, half bandwidth, or even less is called the SRS, which is having three values 0, 2, or 3. This is one I quoted from 3GPP table. It's very long table up to 0 to 62 combination. And here I just showing examples for this particular part, which is showing that CSRS at this value was 30. This is related to the channel bandwidth. So assuming that now in this case we have maximum number of resources is 128. So if you are using this parameter as 0 BSRS, this means the SRS will be transmitted along the full bandwidth. Assume now you moved from BSRS 0 to 1. This means now your resources will be half for the SRS. This means now you will split your bandwidth instead of transmitting the SRS over the full bandwidth. Now you transmit it over the half bandwidth only. As you can see here, only 64 resource blocks will be transmitted. In this case, your power can be doubled because you just like instead of transmitting over the full bandwidth, you'll only be over the half bandwidth, and you can have a gain in the edge user for the SRS, and this can have many other gains as a reflection for the improvement of the SRS coverage. And as I told you, you can see the video for SRS if you need more details about this one. So moving forward now, how to verify this one from field testing. Okay, here I assume that I moved from BSR 0 to BSR 1. So now you will be transmitting over the half bandwidth, so your power is supposed to be increased and your coverage is supposed to improve. So the first part you need to verify from the field testing, you need to check whether this particular UE is supporting again the SRS or not. SRS UE capability, it's through something called supported SRS export switch. If this part is not available in the UE capability, you couldn't find it. In that case, this means this particular UE is not supporting SRS, so you cannot use it for field testing. Or if you find another point, if you find the same, but you find that this should be having equal number, for example, transmitter and receiver, or if it's different, again, it must be showing this part and the capability. If it's showing not supported, then you cannot use this particular again. And how to confirm from the configuration whether the BT Junior B have changed the configuration or not? You can check RRC configuration message, SRS resource to add to mod list. Under this one, you'll find something called SRS resource, and this under SRS resource, you find the value of BSRS, which we mentioned in the previous slide. If it's 0, this means full bandwidth. If it's 1, this means half bandwidth. In this case, you can start making the testing and verify your field testing and so on. To verify this point, again, you need to make test at the cell center and or cell edge users, and before and after turning this point. And also you can make additional mobility testing just to confirm. For example, take one sector or one site which is covering a long distance, just to confirm whether you have improvement or not in SRS, and also in the downlink the throughput or any other KPIs. And that's it for today's session. I hope if you like this content and the slides, please comment and make and like the content and share it with your friends. And see you in the next video. Thank you very much.